In this section, we do substitutions to integrate, and we do trig substitutions. We take things that are not trig functions, like this one, but we use a triangle to relate theta to x in such a way that we try to eliminate the either being rational or having x's in there, and convert it into things that have sines, cosines, tangents, things like that. And then we might be able to use some of the rules that we used in section 8.3 to integrate those trig integrals. So they start out telling us what to use for our substitution. But notice inside the parentheses we have 49 minus x squared. Anytime we have a constant squared minus a variable squared, we're going to use this substitution. And where that comes from is this. If we think about a squared plus b squared equals c squared, then if we take two sides and add them together to make the hypotenuse, and one side squared is 49, one side squared is x squared, then the question is, where do all these pieces need to go? So they give us a hint to start out with until we get used to this. If we divide both sides by 7, sine theta, if we call this theta, is x over 7. So if we did the Pythagorean theorem to find this side, that side squared plus x squared would equal 7 squared. If we subtracted x squared from both sides, we would get 49 minus x squared. If we took the square root of both sides, we would get that this missing side here is the square root of 49 minus x squared. So that's what this side is. That just comes from making that substitution. So if we have a constant squared minus a variable squared, whatever is being squared, that's going to be our hypotenuse. Whatever is going to be whatever variable is being squared here, that's going to be the opposite side, and then that's going to be the adjacent side. So we use this to set up some relationships. If we want to get rid of 49 minus x squared, or let's rewrite this and look at it like this. In our triangle, we have the square root of 49 minus x squared. Well, what is this? This is the square root of 49 minus x squared raised to the third power. The 2 on bottom tells us we're taking the square root. The 3 tells us that's to the third power. So on bottom, instead of calling this the square root of 49 minus x squared, we can come up with a trigonometric expression to replace that with. So how are we going to do that? So using this triangle, we can write several different expressions or relationships. This is one of them. Those two go together. If we do cosine of theta, cosine is that square root over 7. So if we're going to replace that square root in terms of our triangle, that square root is equal to 7 cosine theta. So on bottom, where we have a square root, we can call that 7 cosine theta, and that's being squared. We have a 1 on top, but we also need to replace dx. Well, what is dx? If we know what x is, if we know that x is 7 times sine theta, then dx is just the derivative of that. This is supposed to be a 3 here, not a 2. So dx is 7 cosine theta d theta. So where we have a dx, we're going to change that to 7 cosine theta d theta. Now we're going to simplify this. If we have a cosine cubed on bottom, we can cancel that cosine with one of those cosines and gives us a cosine squared on bottom. If we have a sine cubed, we can cancel that 7 with one of those, and we have a 7 squared on bottom. So we could put the 1 over 49 out front. 1 over cosine squared, another name for that is secant squared. And then we have our d theta over there. Now we just integrate this. What function has a derivative that equals secant squared? That one's tangent. So the antiderivative of secant squared is tangent theta, then plus c. Well, that's not our original variable. Our original variable is x, so we're going to use the triangle to convert back to x. So we're going to look at the triangle, and we're going to say, well, what would tangent be? Tangent theta is the opposite side over the adjacent side. So in place of tangent, we're going to put so we have 1 over 49 out front times x over the square root of 49 minus x squared plus c. So we were able to integrate that without even dealing with it with x's really. We just did a change of variable, and we changed it into a trigonometric function. So it's nice when they tell us what to use for our substitutions, but all that does is that establishes our triangle. So if we have a constant squared minus the variable squared, whatever constant squared, that's going to be our hypotenuse. The opposite side is going to be the variable that's being squared, and then this side is going to be a radical. Think about if we square this, we get 49 minus x squared. If we square this, we get x squared, so 49 minus x squared plus this side squared equals the hypotenuse squared. And that's true. Those cancel, so yes. If I square this plus square that, it equals the hypotenuse squared. So we just deal with that little triangle. Okay, let's take a look at the next one. This is another one dealing with sine. So if we call this theta, then we have the square root of 9 minus x squared, and they also tell us x is 3 sine theta, or we could say x over 3 is sine theta. So opposite hypotenuse, this side would be 9 minus x squared. Think about if we square this plus square that, we would get that side squared. Okay, so we need to make some substitutions. So let's find out what do we need to replace that with. So let's write a trig function that involves the square root, and we could actually do this several different ways. We can write one that involves the square root over x. If we do this side divided by that side, square root of 9 minus x squared over x, that's adjacent over opposite, and that's cotangent. That's cotangent theta. So we could replace that fraction with cotangent. And then we would need to replace dx. Well, if x is 3 sine, the derivative of x is 1 dx. The derivative of the right side is 3 cosine theta d theta. So we would replace dx with 3 cosine theta d theta. Now, let's see if we can simplify this a little bit. Tangent is sine over cosine. Cotangent is cosine over sine. We can pull the 3 out front. I have cosine there. D theta. So that gives us 3 out front cosine times cosine is cosine squared theta over sine theta times d theta. Now, if we just kind of look at these, if we were to go back here, that's not a standard antiderivative. If it was cotangent and cosecant, yes, that is an antiderivative, we know, but not cotangent and cosine. So here's what we have so far. Now the question is, how are we going to simplify that? Several ways we might could go about that. We could try to find something that's going to be u and make the rest of it du. But let's do this. Since this is sine on bottom, let's try to change the rest of it into sines. And you'll see why in a minute. If we solve for cosine squared is 1 minus sine squared. Why am I doing that? If I replace cosine squared with 1 minus 2, 1 minus sine squared, then since we have two terms on top, term by sine. So we could do 1 over sine. 1 over sine, what's that? That's cosecant. Sine squared over sine, that's sine. D theta. Now we just need to integrate both of these. Let's see, cosecant is not one of our standard antiderivatives that we're used to doing. The cosecant, if we look that one up, that integrates into negative natural log absolute value of cosecant theta plus cotangent theta. And sine integrates into negative cosine. So we have a 3 out front, negative natural log cosecant plus cotangent minus a negative makes that a plus cosine plus c. Now we just need to take that and convert that back into x's. So we need to find out what is cosine in terms of x's, what's cotangent. So cosecant is the reciprocal of sine. Sine is x over 3, so cosecant is 3 over x. So cosecant we would replace with 3 over x. Cotangent, we've already found that one. Tangent would be x over the radical. Cotangent is the radical over x. Cosine is adjacent over hypotenuse. And then plus c on the outside. We could get it, we have a common denominator here, so we could add those together, but that would just give us 3 plus that square root on top, all over x inside there. So no huge benefit to putting those together. So the whole key here is how are we going to take what we have in terms of x's and make a substitution using our triangle to convert it into trig functions. Now, if you didn't recognize right off the bat, hey, the radical over x is this side over that side, which is cotangent, you wouldn't have to necessarily go straight to that. Notice the square root over 3 would be cosine. The square root over 3 is cosine. So the square root would be 3 cosine. X is 3 sine. So if we replace the radical with 3 cosine and replace x with 3 sine, we would still end up with cosine over sine for this part. And then we would have to find dx like we did, and we replace dx with 3 cosine theta d theta. So if you don't recognize right off the bat how to replace all of that, fine, do it in pieces. That is okay. All right, let's take a look at the next one. Here, notice we have a constant that's a perfect square plus a variable squared. And when we do that, we're going to use a substitution that's tangent. Hypotenuse is going to be the square root of the constant square, the squared, and the variable, the squared. I think generally we put the variable there and the constant there. Notice Pythagorean theorem. This side squared plus the other side squared equals the hypotenuse squared. So if we want the hypotenuse, square root of both sides. So yes, the hypotenuse is that square root. Notice the substitution, they tell us x over 6 is tangent. X over 6 is tangent. But whether they tell us to make x equal 6 tangent or x over 6 equal tangent, constant squared, variable squared, this is the way we're going to draw our triangle. The thing that's being variable that's being squared, the constant that's being squared, and then the square root there. So let's make our substitution. So let's begin by solving for x. We need to replace x squared, so we need to know what x is first. Well, we have that given to us. X is 6 tangent. That means x squared would be 6 squared tangent squared. We need to know what dx is. If x is 6 tangent, dx is the derivative of that, so 6 secant squared theta d theta. About 36 plus x squared. So let's isolate the square root. So notice the square root over 6, the square root over 6, that's instead of adjacent over hypotenuse, which would be cosine, this is the reciprocal of cosine. The reciprocal of cosine is secant. So if we isolate the radical, that square root equals 6 secant. So how do we turn this into 36 plus x squared all squared? Well, we would raise it to the 4th power. If we squared that, it would just make the square root go away. We would need to take that and square that, which is equivalent to raising it to the 4th power. So that square root and that square cancel. So 36 plus x squared to the 2nd power equals 6 to the 4th times secant to the 4th. So let's see what we have. Squared 30 tangent squared theta dx is 6 times secant squared theta, and then that denominator is to the 4th times secant to the 4th theta. That's a lot of stuff to substitute for. But we knew x, so we could get x squared. We also could get dx. We knew this radical, so we could get that in terms of our triangle. So we have 1, 2, 3, 4 powers of 6 on top, 4 on bottom. So all those 6's cancel. We have a secant squared here and a secant to the 4th there, so that makes secant squared on bottom. Does that leave us? That leaves us tangent squared on. Secant squared on bottom. Now, some of you might say, well, hey, if u is tangent, du would be secant squared d theta. That would be true if the secant squared was on top. But this secant squared is on bottom, not on top. So while that sounds good, that's not going to quite work there. So let's see if we can simplify this a little bit. Again, there's several ways we could go about it. We could try to change into sines and cosines. Tangent is sine over cosine. So that would be sine squared over cosine squared. Secant is 1 over cosine. So secant squared is 1 over cosine squared. If we're dividing by a fraction, that's the same as multiplying by the reciprocal. So we could call that secant squared over cosine squared times cosine squared over 1. So all of that simplified theta d theta. So now the question becomes, how do we integrate sine squared theta d theta? So in section 3, that is equivalent to 1 minus cosine of twice the angle over 2 d theta. So that 2 we pull out front on bottom, and then we integrate 1, and we integrate cosine 2 theta. So 1/2 times, when we integrate a constant, we pick up our variable. When we integrate cosine 2 theta, we're trying to make cosine u du. So if u is 2 theta, du would be 2 d theta. So if we put a 2 there, we need a 1/2 there. So we're going to have a 1/2 times the integral of cosine is sine. So this 1/2 is here. When we integrate 1, we picked up a constant. When we integrate cosine 2 theta, we got 1/2 sine 2 theta. But we have to change these back to x's. This is theta. We don't have a triangle that is 2 theta. We can't just simply find out what is sine of theta and then double it. So we need to express this in terms of the angle we have, 1 theta, not in terms of 2 theta. So we have to use an identity. So we have a 1/2 out front, that's theta, and sine 2 theta is equivalent to 2 times sine times cosine. A double angle identity. So that 2 and that 2 cancel, so we get 1/2 theta minus sine times cosine. So we just need to replace each of these pieces using our triangle. So let's start with, we're going to come back to the theta. Let's start with sine. So on this triangle, sine is x over the radical. X over the square root of 36 plus x squared. cosine using the triangle is 6 over the radical. Well, what is theta? Well, we can actually find several expressions for theta. But let's take the simplest equation that involves x and theta, and that's this one. X equals 6 tangent theta. Or we could say x over 6 equals tangent theta. If we solve that for theta, we can take inverse tangent of both sides. Inverse tangent of the left side, inverse tangent of the right side, and when we do inverse tangent of tangent, since those are inverses, they cancel each other out, so theta is inverse tangent of x over 6. So notice we still have a trig expression in here, but it's all in terms of x, not in terms of theta. Also, you could think of it, if this is our angle and that's our ratio, if we want to rewrite this, then when we take inverse tangent, our input is the ratio, the output is the angle. So inverse tangent of the ratio is equal to the angle. Only thing left to do here is simplify the product. If we do a square root times itself, then on bottom, that would make 36 plus x squared. So that the integral was a little bit trickier there after we got to the point where we were, once we got it simplified here, that integral, we had to make a trig substitution using an identity just to get it to something that we could integrate. Then once we integrated it, our integral was in terms of the wrong variable. It was in terms of 2 theta. We need it in terms of 1 theta. So these are all identities that you're going to have available for the test. You're not going to have to memorize every single one of these. But do be used to how these are used. All right, maybe one last one. Let's take a look at this one. Okay, so let's take a look at this one, and they give us a hint to complete the square. So if we look at the denominator, 2x minus x squared, we want to try to rewrite this as a variable squared and then a constant squared. And the variable part is going to be the one that's negative. Notice our x squared is negative. So we're going to try to put it in this format. So let's start out by factoring a negative out. So if we take a negative out, we could call this x squared minus 2x. So if we take half of this number and square it, we would get plus 1. And if we add 1, we also have to subtract 1 to keep it equivalent. Well, we don't need this 1 here on the inside. So if we take that 1 out front, once it comes out of the parentheses, notice that negative has to be multiplied by. This is minus 1 here. This is minus a negative, so that's really going to be a plus 1 when we take it out. So 1 minus that. That factors to x minus 1 squared. So that's what we have underneath the radical. We could rewrite this as x squared, the square root of 1 minus x minus 1 squared dx. Okay, so let's move that around a little. So now if we look at a triangle, we have a constant squared minus a variable squared. So our constant that's being squared goes there. The variable part that's being squared goes there. And then the square root of 1 minus x minus 1 squared goes there. If we wanted to check to make sure that was right, think about it. If we square this bottom, we have this. If we add that squared, we would have that, and that should equal the hypotenuse squared. This negative and that positive, those would cancel, so yes, using the Pythagorean theorem, that's true. So let's come up with an expression for the denominator. We call this theta. Notice the radical over 1, that's the ratio cosine. Cosine is the radical over 1. On bottom, we're going to put cosine. Now we need to come up with an expression for x. Notice x minus 1 over 1, that's sine, opposite over hypotenuse. So sine is x minus 1 over 1, which means x is sine plus 1. Add 1 here, add 1 here, so sine plus 1 is x. We're replacing x squared. So if we square both sides, if we square that, we would have sine squared plus 2 sine theta plus 1. Sine squared plus 2 sine theta plus 1. Now we need to replace dx. If x is sine theta plus 1, dx is just the derivative of that. Cosine theta plus 0 d theta. The derivative of that. Dx cosine theta d theta. So that cosine's on bottom, that one's on top. So we have sine squared twice sine and then plus 1. Now we integrated sine squared on the last problem. So let's go back and get that integral. When we integrate sine squared, we get it comes out to be this. That's the integral of sine squared. Remember where that came from? We had to do our substitution, then we integrated both of those, and that came out to be 1/2 theta minus sine times cosine. Theta minus sine times cosine. Plus, when we integrate this one, the integral of sine is minus cosine. And when we integrate a constant, we pick up our variable. Okay. So we have a 1/2 out front. Times cosine. Positive times negative, so minus 2 times cosine plus theta plus c. So instead of writing plus theta again, theta and theta, that would have a theta from here, a theta from there. So let's do this. 1/2 times sine times cosine, and then if we multiply times there, 1/2 times 2 cancels, and that's cosine. So we just distribute our 1/2 to each of those. So now using our triangle, we just need to replace sine, cosine, and theta. So let's start with sine and cosine. Sine is x minus 1. Cosine is the square root of 1 minus x minus 1 squared. Cosine, again, is the square root of 1 minus x minus 1 squared plus c on the end. So 1/2 sine times cosine minus cosine plus c. Now theta, there are several different ways we could get theta. We could just take this one. If sine theta is x minus 1, take inverse sine of both sides. So theta is inverse sine of x minus 1. Inverse sine of x minus 1. We could have also gone here and done inverse cosine of both sides and said theta is inverse cosine of that radical. Those two things would be equivalent.